Hello, everyone. Am I audible to everyone?
On behalf of Shri Vaishnav Vidyapit Vishwavidyalaya, Indore, I, Ankita Jain, feel privileged to welcome our speaker, our expert speaker, Mr. Anush Tiwari, Project Manager, Navita's Green Solution Private Limited, Surat, Gujarat, and my colleagues and all the participants who are watching this webinar on energizing the grid with solar energy. Now, before starting the session, let me introduce our speaker.
Very good morning to all. Before starting this session, let me introduce our expert speaker to the audience, Mr. Anuj, close to 6 years of diversified experience.
And some here.
In the field of solar industry, he brings expertise in engineering combined with business acumen. He has designed and commissioned projects more than 15 megawatt solar rooftop and given consultancy for 300 megawatt ground-mounted projects in India and African region. He holds a bachelor degree in electrical and electronics engineering from SVVV Indore. He has deep understanding of this sector and has core strength lies in evaluating technologies and solutions, which help Navita Solar in executing projects globally. Now, I welcome Mr. Anush Tiwari sir for this webinar. Now, without any further delay, I would like to invite our expert speaker, Mr. Anush Tiwari sir, to start the webinar on energizing the grid with solar energy. Anush sir.
Yeah, thank you so much, ma'am. And really, it's a great honor for me to get a chance to represent myself and the Navita Solar on this webinar. And definitely, it is going to be a fruitful webinar to all the students and the participants along with the faculties. So definitely, after graduating from the electrical engineering department from the Vaishnav College University, really, it's a very great career for me ahead. And I decided to join the company in the renewable industry because the curiosity of the electrical engineering knowledge would be applied to the real world. So my main intention is to join this renewable industry to understand that what are the benefits related to the environment we can get it, and other pros of joining this renewable industry. So after working in the Navita Solar company, definitely I got a 5 to 6 year almost completed, and there are a lot of inventions and my thinking I have applied into this industry, and I have designed a lot of projects related to the ground mounted project along with the some rooftop project also. So that is the just brief about myself. So without wasting much time, I will let's start the presentation. So basically in this presentation, I am going to target the technical parameters along with the what are the benefits of installing the solar plant in the commercial, industrial, as well as the ground mounted projects. So I'm going to share the screen with everyone. Okay, so I hope the screen is visible to everyone. Okay, so basically, topic of this webinar, I've selected the energizing the grid with the solar energy. So the reason behind selecting this topic for the webinar, you can say or training also, a small minor training kind of thing, where I'm going to educate the student as well as the professionals that what exactly we are doing in this industry and how it is beneficial to the customer as well as the government, and how it is beneficial to our environment as well. So let me start the presentation. And okay, so basically as I already told that currently I'm working the Navita Solar. So related to the technology, we don't have to dream about the clean energy. We have the technology, we need to create the clean energy for us right now. as we are living in this technology world, so definitely we have a great opportunity together. We can happen for everyone and everywhere. So basically the picture which you are seeing currently, this is the Navitas solar company, and where we have designed the system with writing a letter of Navitas. So basically this is a 200 kilowatt system. So just to show you that in this industry, a lot of innovations and creativity is there where an individual engineer can put up in their industry. So let me brief something about introduction about the Navitas Solar. Basically, we are the module manufacturer currently, and I'm definitely in this presentation, I'm going to show you that how the modules are manufactured in the company and what are the technologies we are using for the production of the modules. And basically, we are in this industry from last 7 to 8 years, and definitely we are making up the market good, and we are creating a efficiency in solar panel class efficiency we are maintaining. That's the thing. And we have a nearby turnover of 10 billion in Indian rupees, and we have a group of companies, and definitely a group of companies, the Mahati industry, which is in the electrical transformer industry from last 50 years. And along with this, some good groups like Singhania Group, Sun Matlick, and recently we have started the India's first lithium-ion battery manufacturing company as well. So being this discussion about the group companies, so let me come into the main part. Okay, the agenda, or you can say the content of today's presentation is to introduce how photovoltaic cell works. And I'm going to discuss about the modules, technology, components, and different configurations of the solar PV systems and on-grid solar PV system, type of software for using and designing the solar photovoltaic, and the different policies which has been made by the government, that what are the beneficial to the customer and the individual as well, and how it have impact on the solar career, what is the opportunities you have to work in this solar industry. So definitely I'm going to discuss each and every topic in a broadly, and in that topic I'm cover all the things which currently all the participants are interested to know about this industry. So let me start the presentation of the first slide. So before giving you the description and the detail about the modules and everything, I want to show some video that how the solar cell actually work, because in this webinar there are a lot of students as well as the professionals, faculties, everyone is there. So I want to just tell them that how the solar cell work as in an environment. So let me start this video.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the P-N junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the N side, while the hole is drawn to the P side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades.
Okay, thank you so much for watching this video. So, moving to the next slide. I'm going to explain that how these cells are made and what are the process involved in making the cell. So basically, if you will see from left to right, I'm going to define that silicon. Basically, this is material is available in the south eastern countries, and we are definitely this silicon and everything process is done currently in the China and the other country, and India also we have started this process. So for the in India there is less companies who are doing this process. The reason behind is that the cost of setup is huge, and silicon availability in India is not in bulk. So that's the reason other countries are definitely manufacturing these cells. Okay. So now silicon is really available material in the environment. Then we convert into an ingot. Basically, ingot process is known as the Siemens process, where the cells has been divided into two categories, polycrystalline as well as the monocrystalline cell. So poly and mono, they have a polycrystalline cells. Definitely, it's a multicrystalline cells, and monoperc and the monotechnology cells is the single crystalline cell. Then it is converted into a wafers. So basically, wafers we are currently taking from the Taiwan and the Thailand and the China. These are the three major countries who's the distributor of the wafers. And then we cut into a cell process, and then we stack all the cells in a series parallel combination to generate the voltage and the current. So this is the general process of module technology, where we follow each and every industry in the solar follows the same trend. And I'm going to show in the video also that how the modules are manufactured once the cells get reached in India. So already I explained that before the process between silicon and the ingots, there are two different kind of cell, which is mono poly amorphous cells, and divided into two phenomena, that is silicon based wafers and the thin film. So basically I'm going to brief something about the silicon based wafers. So mono and the polycrystalline have an advantage of efficiency. So polycrystalline have a better good efficiency, and I can say monocrystalline have a better efficiency compared to the polycrystalline. And the thin film is the basically a different kind of category where the pure crystalline cells are used to get a maximum output from the cell. Generally in India, we have a trend that we generally use the polycrystalline, monocrystalline, because the temperature coefficient is quite good as compared to the Indian climate. And the thin films are used in the areas where there is having a low heat and the high insolation level of the sun. So that is the reason we are using in India the poly and monocrystalline, and thin film are readily used in our some projects. So it is great to know that I'm going to tell you that in the area of Leh Ladakh region and the north area of the Indian country, so Leh Ladakh, Jammu and Kashmir, so where we can prefer to use the thin film because the insolation is quite good and we get a good energy generation from our modules. So that's the some about the thin film and the silicon based wafers. Now come to the point that how basically solar system works. So I have here typically represented the residential sector. I am going to cover the commercial sector also, that how the solar PV plant works generally. So you will see that there is a frame module mounted over the roof, and then we are connecting with the junction box. And connecting the junction box, it's basically combining the DC voltage and the current in the junction box. And then we with the DC cable, basically in solar we use the generally special type of cable, we call it as a XLPO, cross-link polyolefin cable. So that is a totally UV protected cable, and we follow the different standards for using this cable. Currently we are using the 4 square mm cable, which is performing good at Indian climatic condition. So Now coming to the array junction box, it's a basically isolator. You can tell it as an electrical MCCB kind of thing, and then we put the inverter. So basically, the main function of the inverter is to convert the DC into AC. So whatever the inverters which are there in India currently, they are all exported from the other country, imported from the other countries, and definitely Germany is the country which is in advancement of technology, and they are manufacturing a good inverters and having a good reliability as well. So then after the output of the inverter, we connect to the distribution box, and then we connect to the grid. So basically this is the not a big plant, it's a small segment plants, residential and the commercial plant sector, that how actually the connections are being made to get and power from the solar. So now in the industry is moving to the residential sector because the government is supporting residential sector, and also releasing a good policies and the circulars which are beneficial to the customer as well as the mass in mob also. So that's thing. And the different configuration of solar PV system. So in the industry, there are 4 major different kind of installations. So starting from left to right, if RCC roof is there, is the general installation procedure which generally we use in the sector. And nowadays the government buildings and everyone is maintaining this type of installation. The advantage of getting a RCC roof installation is that we are utilizing the roof and we are not any utilizing ground area, and nowadays the land cost is huge in the Indian cities, in metro cities. So people are preferring to install the solar plant over the RCC roof. The advantage is that we are saving the land. Along with that, we are utilizing our roof, which is not of any use there. So we are using this type of installation generally in India. Now coming to the next type of installation, that is the GI shade. So what GI shade? It's a common industrial shade which we are currently using this, because the industrial getting a lot of electricity bills, and nowadays the government is also supporting the industrialists to use the solar PV system, and also they get a lot of advantage of while installing the solar PV system, because most of the time daytime power they consumes from the solar, and definitely they save a huge amount of electricity bill while using this solar PV system on industrial shade. Now the third category, which is in India generally, is their ground mounted system. So the system which is having a size more than 1 megawatt or 2 megawatt. So basically they all are the ground mounted projects. So recently you came to know that news about the 750 megawatt plant in the Riva. So basically the same system, we called it as a ground mounted system, where a utility supply is there, and we are selling the electricity to the government, and the government is paying with the whatever the credit we have signed in the PPA. PPA means power purchase agreement, so with the government, and this electricity has been used by some great power industries like NTPC or other huge power generation companies. So they are using this power for their production and other benefits. So this is and the latest trend which are coming in the market, that is the floating solar. The advantage of using the floating solar is that we are using the water bodies for the solar plant installation. The reason behind using the floating solar is that we can utilize the canals and the other rivers which are definitely nowadays seeing the climatic condition, not much water is available inside a river compared to the past 10 years report. So definitely still there are some canals where we can utilize for this type of installations. Now coming to the next slide. Now, which I was talking earlier, that that was the residential and the industrial sector installation. Now coming to the on-grid solar PV system. So now using the on-grid solar PV system is that this type of system installed in a utility scale, where a huge centralized inverter are used and the transformers are used, and we are supplying the electricity to the government, and the government is selling to the major power generation industries like NTPC, Hindalco, and the or consumptions are there. Many good companies which are there in this sector, where utilizing the solar power for their production and for their generation part of view. So they are consuming the solar power and saving a lot of energy, And definitely in the renewable industry, a lot of things are innovative things are going on, where the target is to meet up the cost of the present electricity, where we, while using solar power, we can reduce the cost of electricity per unit. So this, and let me brief about this system. Basically, it's a, although the DC part remains same in all industry, we are connecting a DC module, solar modules in a series parallel combination, making a current, voltage, and other things. And with this centralized on-grid inverter, so we are supplying the power to the inverter, which convert DC into AC, and then we are stepping up the transform power with from 440 volt to 11 kV, 22 kV, 33 kV, whichever is the nearest grid available for connection of the system. So basically, this is the general functioning of the utility grid system, and these are installed in acres. I can say for installing the 1 megawatt system, nearby 3.5 to 4 acres of land required for installing such system. So in India, there are still some areas which are having non-agricultural land, and we are using that for the solar purpose. So this is all about the on-grid system, and I'm going to cover in the next slide as well. So now the generally what kind of software we are generally using for the installation of the solar PV plant. So basically, in the industry, there are a lot of software available for designing the system. But generally, if I recommend that, there are the 4 major software generally everyone used for designing the solar PV system. If I talk about a residential, commercial, and the utility solar plant, so we are using the 4 major software, and one of them is the Google Earth. Google Earth gives the image of the area where we want to put up the solar plant, and accordingly we used to take out the latitude, longitude, altitude of that area, and we used to put up this data into our PVC software. What is PVC software? Yeah. Okay. So PVC software we are using for the consumption, for taking out the annual generation of the solar PV plant, and we are using this software for identifying that how much of generation we can have in the particular area. So then I'm coming to the AutoCAD. Basically, AutoCAD, everyone knows that AutoCAD is used for designing the systems and for the residential, utility, and there. So once the AutoCAD file is designed, then accordingly you can put up your system on the land, and you can get an exactly the things which you have designed into the AutoCAD file, and accordingly you place the equipments and you place the panels, modules, everything as per the AutoCAD. And the last one is the SketchUp. Basically, the SketchUp software is used to identify the shadow over the plant. So it is very essential software to know that how much shadow is coming over the plant, and accordingly we used to just put the system, and we design the system. So this is all about the software. Now what are the processes involved in the installation, the commissioning of solar PV plant? There are majorly 8 processes involved: doing a site survey, analysis, equipment, financial modeling. Financial modeling means that if whatever cost of consumption of electricity is there, so while installing the solar PV plant, how much electricity we can save, and how much saving will be there throughout the years. So that is used for financial modeling, INC, O&M services, power evacuation, engineering design, and this. So these are some processes which are involved for setting up the solar PV plant. It might be for the rooftop, commercial, or the utility. So we follow the same process for commissioning the plant in the industry, renewable industry. Now, everyone might be heard that what is net metering policy? So net metering policy, basically it's a policy made for the residential and the industrial sector. The advantage of this policy is that whatever the power you are consuming from the daytime, and suppose you are consuming a 50% power from the solar, and still the 50% power is available, which you cannot use it because your load is not that much while consuming the solar power, then the advantage of the net metering is that you can give this power to the grid while installing the bi-directional meter. So bidirectional meter is just kind of meter which used to import I can say it's a meter which import and export reading are recorded, and accordingly government set up the cost of electricity bill. It means that suppose I have supplied 100 unit to the government and I have consumed the 50 unit from the utility grade available like MSCB or MPB grade, CSCB grade. So while importing and exporting the units, so the net unit which we give the electricity bill, that gives the all details about your consumptions of unit from the solar and the grid. So it's a bidirectional, it's a setup of unit where you are giving, exporting and importing, and the net, whatever the benefit you are getting, that you are paying to the government. So this is all about the net metering. Every state have a different policy for the net metering. MP, Maharashtra, Gujarat, so every state has a different policy according to their state government terms condition. Now, this is the most important slide which I have prepared for the students and the professional. Nowadays, it's very, I guess this industry, people knows about it, but currently the student which are passed out or the student which are coming to the college, so they think that the renewable industry, what are the career growth opportunities is there on the renewable industry. I can say there are a lot of opportunity in this renewable industry. If I talk only about the solar, so there are 4 different divisions are there in the solar industry, where you can show your creativity and you can be an employee there and you can show your talent there. So basically there are 4 major industries like manufacturing industry, which Vitas is there. The system designing, where you can have a lot of opportunities in the designing part, project development, and the installation and commissioning. Now coming to the manufacturing. Manufacturing can be of a module manufacturing, inverter manufacturing, cable manufacturing. So there the different field which we generally hire. The engineer is from the environment engineer, electrical engineer, mechanical, industrial. So these are the some good branches which can come in up in the manufacturing division. The second division comes system design. Every engineer have a different concept of designing the system. So there is also a lot of scope of the IT sector as well, because there are different softwares which we are using in this industry. So there are a lot of scope for the IT people as well, and the software engineer also, power system engineer. So that is the thing. And if I talk about the project development involves all type of engineer, because you need to have a good knowledge about the design and equipment as well. So because this is the major role which has been played by this project manager and the project team to execute the project. Sorry. Now coming to the installation and the operations. This is basically an INC, in short we call it. Installation and operation involves the solar instructor, installer. So these are the some field which are available in India, and definitely lot of potential is there for all the engineers as well as the professionals to have their career in this solar. Because everyone thinks about this industry is new to India and what will be the career growth, and after 10 years where they see themselves. So being an electrical engineer, and definitely I can say that there are a lot of potential in this industry. So if you are going to start your career with the renewable industry, down the line, if I see after 10 years, you can find yourself in a good reputed organization, and also you can see yourself as a good electrical engineer or any good engineer. So because the industry demands a lot of engineer, because this industry have a lot of opportunities in the manufacturing, designing, installation. So the manpower required a lot, and in India is a country where every, I can say, college have a good engineer, but currently the scenario of COVID-19 and the corona is still in this industry, no such impact is there of corona or COVID-19. So definitely I can say that this industry will be a great opportunity to all the pass out batch and upcoming batch for that. Now, I'm going to share video of module manufacturing. What exactly, how it is, we are doing the manufacturing of the module, because there are some companies which do not share their manufacturing because of some, I can say, confidential machines and things there. But being a Navitas Solar, we are very much transparent company. We want to show the student, a professional, how the manufacturing is done of the solar module. Thank you so much for watching this video. So this is all about the Navitas, and definitely from this video I can say that this is the 200 megawatt line which is there in the Surat head office, and if someone wants to visit this factory can see the entire line and the process of manufacturing of the modules. As you have seen that there are a lot of process involved in the manufacturing of the modules. It's just like that. Cells and cells generally we are importing from other countries, and definitely assembling of the cells, making a series parallel combination with the laminators, EVA sheets. So these are the some terms used in the manufacturing industry. So after all such process, there are one process we call sun simulator test, where we used to perform the testing of the modules and to get the exact STC condition. STC means standard test condition. So it's just all about this process which involved in the manufacturing of the module. So definitely I would like to say thank you everyone for watching the slides, videos and everything, and being, as you have might have a lot of questions in your mind related to this presentation. So I would love to invite the participants who can directly ask the questions, or you can just put up your question into a chat box. So over to you, ma'am.
Thank you, Mr. Anuj sir, for sharing your valuable knowledge with us. Now, dear participants, if you have any question regarding the session, you can write in the chat box or QA box. We have already have 2-3 questions. First question is use of PV SYST.
Okay, so basically, it's PV Syst is the term which call it in the industry. PV Syst is the software where you can put up your parameters for designing the system. If I see that if I am going to design a 100 kilowatt or 1 megawatt system, so for calculating how much of how many modules or the inverters required for generating a 1 megawatt plant. So for that we used to put the PV Syst, and generally it give the entire scenario of 1 year, how much generation will going to happen after installing. So definitely PV Syst software gives the lot of details about the solar PV plant, that while designing the system. I can say that PV Syst is the software which are approved software from the government for designing the solar PV system, and the report which get generated from the PV Syst software that need to be submitted to the government if you are doing any utility project. So on the basis of PV Syst report, you can take out the generation, because there are a lot of factors which are involved while designing the system. Because if you are designing the system under shadow condition and you are expecting the full output from the solar module, that is not possible. So there should be a shadow free area over the system, then only you can take out the maximum generation from the PV Syst report. And PV Syst report is the widely worldwide used software, and this software is also available for the student version as well. So they can use this software for the practice and for the small scale project. So this is all about the PV Syst software.
How much electrical energy is required to make a 1 megawatt solar panel?
It's not about making the solar panel. We are generating the power. So from this 1 megawatt plant, if I have commissioned, then I can generate solar energy nearby 14 lakh to 15 lakhs unit yearly. So we are just after putting up a solar utility project of 1 megawatt ground mounted project. So maximum energy which we can generate between 14 lakh to 17 lakhs. So the figure 14 to 17 lakh depend upon the system design, how precisely and what are the parameters you have considered while designing the system. So you can generate a power of 14 lakh to 18 lakhs unit, 17 lakhs unit yearly from this 1 megawatt system.
Last question. Does it require any government approved license to take solar power plant contract?
See, there are two kind of system where you need to take in permission from the government. One is the residential and the commercial sector, where you don't require much government approvals, But if you are going for the net metering, already I explained in the slides that what net metering. So for that, you need to submit some technical documents to the government where they used to come at the site and see the system and approve it. And if I talk about the utility scale project above 1 megawatt, 10 megawatt, 750 megawatt, so in that case, you have to take a lot of approvals from the government, like CIG approval, Chief Electrical Inspector approval, and before installing of the plant, land approval, and then their nearest substations are there, which you need to connect the system. So you need to take a lot of approvals from the government before setting up any utility project from the government. So generally the procedure is that government release the tender for the utility project and you used to bid that tender, and if you win it, then the all such licensing process start with the government. So definitely for residential and the commercial sector, no such big approval required. Just you need to take a sanction from the government in a paper, that's it. And rest for the utility projects, you need to have a lot of things which get involved in the licensing process. Yeah.
Next question. How much area is required for 1 kVA generation?
Please, ma'am, pardon. I'm not getting.
How much area is required for 1 kVA generation?
See, if you are installing your plant over the roof, RCC roof of 1 kVA, then it's a 120 square feet is the area required for 1 kilowatt system. And if you are installing your system over the GI shade, industrial shade, then you can consider it as a 8 square meter area for normal installations. So it depends upon the roof availability for the installation of plant. Yeah, next question. If
Next question is, according to your experience, what are industry demands from an electrical engineer fresher in renewable field?
Yeah, definitely. This is a nice question, and I was expecting this question in this webinar, and definitely I can say that there is a lot of requirement of freshers as well as the electrical engineer who passed out recently, because this industry is growing a lot, and as the government is supporting the Make in India concept and all the industries which are there in the India, also some good industries are coming into the India for setting up the manufacturing unit and other things. So definitely there is a huge potential in this renewable industry, and I can see that next 10 years you are going to have a lot of opportunity in this sector, and also presently also there are a lot of opportunities, and being as an electrical engineer, I can recommend that this industry is much beneficial to the electrical, mechanical, civil engineer more compared to the other sector, because this industry is growing huge in demand, and definitely for the fresher there are a lot of opportunities. And if I say about that, Navita soon is going to conduct a training for the professionals as well as passed out engineers or the students which are coming up in the electrical branch, and that is going to have a lot of knowledgeful and fruitful training to the student as well. So, and they will also get a good opportunity in this sector, because as seeing the engineering, a lot of things are involved. So I can say this thing. Yeah, next question.
Next question. Is there any training provided by you for freshers by your company? Please tell us the procedure.
Yes, soon we are going to have a training session for the students, and currently the course has been designed, and by the next month definitely we are going to have a training session for the students, and that will cover all the topics related to the solar installation, and they will be getting a hand-on experience as well from the company. Yeah. Next question, please.
Is there any Hello.
Yes, yes. Yeah, next question.
Do we use MPPT in solar plant?
MPPT. Yeah. Basically, the term MPPT is the maximum power point tracking. So this MPPT term we generally call is at the maximum power which get generated during the peak hours of the solar generation. Generally, the maximum power which we get in India, that is between 12 to 2 o'clock, where the solar module performs on its higher efficiency. So MPPT is the term used for maximum power point tracking. So for getting maximum power from the solar, we used to have different kind of orientation. Generally in India, we have a orientation of south facing of the solar modules. So basically the south facing, why we use, because India is the country where generate a maximum power while putting up a solar modules perpendicular, I can say having a south facing orientation. It gives the maximum power output from the solar module. So to get a maximum output power, we need to adjust a tilt. We call it a tilt angle or a slope angle to get a maximum output from the solar plant. And the term MPPT defines the maximum power point tracking, which we get as per the slope of the solar modules. If I tell that in India is the country where the southern orientation, south orientation is much being used in the industry, in the Indian countries.
Next question is challenges while solar to grid synchronization.
Yeah, definitely. This is a nice question, and a lot of challenges are there in this industry while synchronizing with the grid. The major challenge is the power quality. As in India, there are different kind of power quality factor involved in this, such kind of the harmonic distortion, voltage fluctuation, unbalanced system, or I can say unbalanced grid or the phase unbalanced. So there are different kind of parameters which involved in synchronization. So it is quite challenging for us as well that the grid stability need to be perfect while synchronizing the system. Although if I go with the utility grid of 11 kV, 33 kV, 22 kV line, 132 kV line, so there is no such big problem related to the voltage part. But the residential and the commercial sector is having a lot of difficulties because voltage fluctuation, power quality, harmonic distortion, because in industry there are different kind of loads are there, like VFD load, variable frequency drives, and different kind of machines are there which generate the harmonic. So bad quality of power is there in Indian industry, but definitely the government is taking a lot of measures to improve the power quality. They are installing a filters, active passive filters, automatic power factor corrector. So this is the thing. But the major thing is the voltage and the power factor, which generally we focus while synchronizing the system into the grid.
Next question. After installing rooftop solar, power factor of existing system falls depending on the size of solar. How one can raise the power factor of existing system?
Ma'am, your voice is not clear. If you can repeat the question, please.
After installing rooftop solar, power factor of existing system falls depending on the size of solar. How one can raise the power factor of existing system?
See, while installing the system, one procedure is being followed in this industry. We used to take out the power factor from the power analyzer. Basically, power analyzer is the equipment which we generally use while before installing the solar PV plant into the existing industry. So if the power factor is less than 0.9, then we generally don't recommend, or we used to put up a APFC panel, is the automatic power factor corrector, which brings the power factor near to the unity. I can say 0.99, 0.98. So generally this power factor is good for the installing the solar plant. And if I talk about the solar point of view, generally the unity power factor is always delivered from the solar. So there is no such issue from power correction point of view, power factor correction point of view. So definitely in the solar, you always get a unit near to the unity power factor, not near, it always have a unity power factor. And we always give the stable voltage supply. That is the answer.
Thank you. Thank you, Anil sir, for sharing your valuable knowledge with us.
Thank you.
Thank you, sir. Thank you. Before concluding this session, it's my privilege to propose words of thanks to all those who helped us in making this webinar a successful event. I want to express my gratitude to our expert speaker, Mr. Anuj Tiwari sir, for sharing your valuable knowledge with us. I extend my sincere thanks to Dr. Namit Gupta sir, Director SVITS Indore, for their guidance and inspiration. I am very grateful to Dr. Upinder Dhar sir, Honorable Vice Chancellor, Sri Vaishno Vidyapit Vishwavidyalaya Indore, who gave us the opportunity to organize this webinar. I also offer my sincere thanks to all my colleagues and participants for being with us. We are looking forward for your future participation. Thank you all. There is an announcement for the participant. The feedback link is given in your chat box. Kindly submit the form to get e-certificate. Thank you. Thank you for being with us. Have a nice day. Thank you, Anil sir.
Thank you so much. I would like to thank everyone from the professors and our faculty, great faculties. And it's been 6 to 10 years. I am seeing all the faculties. Ankita ma'am, Jaya Sharma ma'am, Anil sir, and special thanks to the professors who got definitely a lot of things, and I have learned a lot of things from the professor faculties. If I talk about, and major thanks to Anil Jain sir, who were the HOD at our time, and a lot of knowledge he has shared with us. I can say an academic knowledge advisor. So being a student in this SVITS, definitely I have learned a lot of things. If I talk about from the cultural activities to the sports activity, if I talk about the lectures and other things. So definitely it's a great opportunity for me to represent myself in front of Navita, in front of SVITS Indore. And definitely I will recommend all the participants and the students, kindly please have a bright future in the renewable industry, and a lot of potential is there in the renewable industry. And special thanks to the Namit Gupta sir and the Upender Dhar sir for giving me the opportunity to show myself and to present myself in front of SVITS. And looking forward, and also I can say on behalf of Navitas Solar that soon we are going to have some good sessions related to the technology and other things. And also we are inviting all the students who want to see our setup, who want to see our plant. They are most welcome, and we have some good plant near to the Indore region as well. They can go and visit the system and learn a lot of things from the solar PV plant. And if any queries or if anything is there, get me in touch with the LinkedIn profile is there. In the name of Anuj Tiwari, you can just put up your message and you can ask your questions, and I'm here to answer each and every questions. And thank you so much, ma'am, Jaya ma'am, Ankita ma'am, for organizing this presentation.
Okay. Have a nice day, all the participants also.
Thank you. Thank you, Anil sir.
Thank you, ma'am. Thank you.